Now we'll see one more problem which is asked in GATE 2003. So consider the following C variable declaration. One is int star a of 10, second one int b of 10. Now out of the following expressions, which of the following gives compile time error? So when generally you get compile time error when something used at left side is value. So the question is like this. If you write 2 equal to x, then it gives a compile time error. It says that L value is required at left side. So always left side we should use something so that should corresponds to address. Okay. So since 2 is a value not related to address, this gives an error. So now the question, do we have any construction similar to that like this one? Right. We'll see now. Let's begin with a of 2. Okay. So what is a? A is a array of, we know the how to read the declarations, right? A is a array of 10 pointers to integers. So how to imagine that? This is a structure of such int star array of 10, right? It is an array of 10 integer pointers, right? Each one is integer pointer. Remember, okay? Maybe x1, x2, just imagination. Assume that values are x1, x2, x3, x4, x5, so on, but we did not, fill them, but imagine, right? We can fill them. Now, what is x1? Integer pointer. What is x2? Integer pointer. Now, what is a of 2? This is a, array A, then this is a of 0, a of 1, a of 2. That means x3, right? A of 2. Now, the question, can we write a of 2 equal to something? That is a question. Which of the following gives compile time error if you use them left hand side? If I use a of 2 at left hand side, it should not give compile time error. The reason I will tell you. I use common sense and I answer this question. If a of 2, if you use at left side, if it gives error, then what is the way? How can you use this array? You cannot fill these boxes, right? Because to fill these boxes, definitely we have to write a of 2 equal to something, otherwise a of 5 equal to something. But if it is not allowed, what's the purpose and fun in having one array, right? That's why to have this array, the only purpose I am having this array to fill them. That's it. That's why simply I can say that a of 2 will not give any compile time error. Second one, you see, I'll come to directly 4. Okay. What is b of 2, 3? What is b? B is a two-dimensional array, right? So how to imagine two-dimensional array? Already I told you. This is your b, okay, and that there are two dimensions. One is 10, second one is 10. This 10 means there are 10 rows. 10 row number 1, row number 2, row number 3. I don't show all, but there are 10 rows. Each row has again 10 memory locations. So that means like this, they are 10, okay, 10 in that way. You have such 10 rows. Now, what is b of 2, 3? B of 2, 3 is nothing but this is b of 0, this is b of 1, this is b of 2, and that. So this one b of 2 of 0, 2 of 1, 2 of 2, 2 of 3, this position, right? So b of 2, 3 obviously refers to what? One particular memory location, and to fill this position definitely we have to write b of 2, 3, isn't it? So that's why this is 0, this is 1, this is 2, correct? So I can say that this is b of 0, this one, this is b of 1, which array? This array. So we say b of 2, this one. Then on this array, if you want to access third position, we have to write b of 2, 3, correct? So obviously this will be perfectly correct because we write it, and we know that this kind of syntax exists and which is very popular. Now we'll see two more things. So sir, is it a problem a of 2, 3? It's not a problem, I will tell you. Why? Because after some time in your program, you might, since these are all integer pointers, right? Imagine that we are writing here, this is a of 0, a of 1, a of 2. In a of 2, let's say you wrote a pointer value called x. Okay, x is an integer pointer. After some time, let's say you filled it through the syntax. Okay, then if x is pointing to a memory box, an array, let's say x is, let's say, pointing to an array, we did it. So I will give you the pointer here. Please refer my video where I explain you how to realize a two-dimensional array with mallocs, that means dynamic allocation. On that I use this array and I use this syntax, but here, so I will tell you in a different way. If you refer that, you understand that. Second one, here I will explain you why this is a valid syntax. So example, let's say this is a of 2 position, right? In a of 2 position, if I fill an integer pointer, such integer pointer, let's say pointing to one very big array, then question number 1, using x, let's say really x is a pointer to that, how to access third position in this array? Definitely x of 3, isn't it? If x is really a pointer to this integer array, right? Then this is x of 0, x of 1, x of 2, x of 3, this one, right? Okay, but what is x? X is nothing but a of 2. That's why I can replace x with a of 2. So finally a of 2, 3 is a meaningful thing in programming. That's why when you do this one a of 2, 3, we never get any error, compile time error. And one more easier way of understanding this one I will tell you. A is a, I can say that a is a double pointer kind of thing. Why? Already you can see a single pointer, right? Why it is a double pointer kind of thing I will tell you. A is an array of 10 integer pointers, correct? So already you have integer pointers inside. Okay, now a can be treated as a pointer to, already I told you, when you have an array and the a will be, example, whenever you have an array a, then a can be imagined as a pointer to the first memory location, right? Pointer, a is a pointer. Now already this box contains integer pointer. Now you are a pointer to, a is a pointer to the integer pointer. That means a is a double pointer kind of thing. That's why when you have a double pointer kind of thing, then you can dereference it 2 times. Using this suffix notation, you are dereferencing a 2 times. Why? Just check it out. A of 2, 3 is nothing but, let's expand it. It is nothing but star a plus 2. And one more point I would like to clear, that when you use suffix notation, it doesn't mean that we are dealing with arrays. Okay, so that may not be array. So that's why that is a where you get problem generally, right? So just suffix means what? This one. Whenever you have a of 2, though a may not be an array. Okay, so a equal to, like a of 2 is nothing but star a plus 2 of 3. Then if you do this one, it will be, let's treat it as x. X of 3 is nothing but star x plus 3. So what is x? X is nothing but star a plus 2 plus 3. So finally what I want to say is, you are dereferencing a here once 2 times. Yes, double pointers can be dereferenced 2 times. That's why it won't give error. Okay, in so many ways I explained finally that this is a valid syntax. Now we'll see b of 1. So b of 1 gives compile time error. The reason, b of 1 is what? B of 1 is a pointer to this array, right? That means b of 1 is a pointer to this first location of this array. It's like a array pointer. That means a pointer to the first location of array. Recall, when you have an array like this, single one dimensional array, int a of 10, okay, then can we modify a value? Like, can I write a equal to something else? This is definitely compile time error, because base pointer cannot be modified. Similarly, in this 2-dimensional array, b of 1 is b of 1 is a base pointer to this array. Then if you modify b of 1, then only we have to write b of 1 at left side. When you write b of 1 left side, you are trying to modify b of 1, but it is not possible, because at this moment b of 1 refers this base array, like this array. Then we can't modify b of 1. Modifying b of 1 means starting address of this one. See, this one, starting address of this array you are modifying, but we should not do that. Similarly, modifying a means what? Starting at a is a pointer to the first memory location in this array. Then can we modify that a? No, because it is a base pointer. No base pointer can be modified. Here b of 0, b of 1, b of 2 all are base pointers, and they are especially designed to just to hold the starting address of this array. Then there is no fun, otherwise there is no purpose in modifying them, correct? Because their purpose is only to catch them. And even this is wrong. Writing b equal to something will give you error, because b is a base pointer to this 2-dimensional array, which holds the starting address of that array. Then if you modify that, then you want to move this b to something else, but b is specially designed to hold this array. That's why you can't modify b, you can't modify b of 1 or anything. Okay, only proper syntax is b of 2, 3. Now come to the options. We have options 1 to 4. The correct answer is there is no problem with A of 2, there is no problem with A of 2, 3, there is no problem with B of 2, 3. Yes, perfectly 1, 2 and 4. Okay.